Good morning, everyone, and thank you for joining today's webinar, What is Continuous Optimization, presented by Peter Nikolov, CTO and co-founder of Opsani. Today's presentation will be approximately half an hour long with 10 minutes for Q&A. So we encourage you to pose your questions in the Ask Questions tab. We'll also be posting other resources for you to learn more in our chat room. With that said, I'm going to pass it over to Peter. Enjoy.
Good morning, good afternoon, and good evening, wherever you are. Welcome, and thank you for joining our presentation on continuous optimization, which is a new important step in the application delivery pipeline. My name is Peter Nikolov. I'm founder and CTO of Opsani. Together with my co-founders and some team members for several companies, we have built various important cloud infrastructure and cloud orchestration systems. We have seen the impact that cloud has made to hundreds and thousands of applications. And there's the tremendously good parts, but there's also some challenges that the accelerated velocity and the flexibility of cloud brings. So when you move your application to cloud, what happens? So if you do lift and shift, kind of starting from left to right on this diagram, if you just do a lift and shift, which is the upper path, usually you end up with higher costs than you expected. Yes, you did move to cloud, you don't have to run your infrastructure anymore, but typically the costs end up being higher than what you expected. And if you go further by things that cloud enables, adding DevOps approaches to development and application pipelines to increase velocity of feature delivery, you will also discover that things started happening really fast, which was the objective. But the result of this is that not only the cost is higher, but you now no longer have time to do the optimizations and tuning. So why is this bad? Companies have discovered that costs are higher than they expected after they moved to cloud, and that either prevents them from onboarding additional applications, or as they add more capacity and want higher performance, the costs become even higher. And that is clearly not what they expected. So the question is, well, what can we do? Is there a way to reduce those costs and improve performance? So we now understand what the problem is, but let's kind of understand also why the problem appeared and appears in cloud. So kind of the old model before cloud, before DevOps, is when a new release of your application appears and you have your developers complete it. Then it goes through a build phase, through a manual test in your QA department, tuning, which is usually part of your or performance optimization, and then it gets deployed. And that is the cycle that you repeat on every release. Well, let's add DevOps now. What happens in CI/CD pipeline automation? So again, you write the code. We don't write that automatically yet. And then once the code is there and is committed, the CI/CD pipeline picks it up and does automatic build, runs all automatic tests, and then it pushes it to production. What you will notice clearly is that there is no more tuning. The system doesn't do it, and there is no time or moment to do that. So the result is that your velocity is indeed high, but there is no tuning. Tuning does not happen as part of this process. Tuning disappeared from the process. So when does tuning happen? Because it is no longer part of the pipeline, when do we do it? Well, we do it only when things break. When the performance is really bad, or we start seeing errors and customers start complaining, that is usually the moment when we say, oh, well, we need to optimize. And then the teams will bring the optimization tools and start looking at it. Well, how do they do it? How do we optimize? So there's a number of traditional tools that have been around, things like monitoring tools, application performance management tools. And although there is a great new crop of such tools that are specifically adapted to the cloud, and they work a lot better now and have increased visibility tremendously, the process and by which those are used, the methodology remains the same. Essentially, we use these tools, instrument your code, which again is usually a human operation. You have to understand how the code works by looking at white box analysis, seeing events and timing of various procedures and functions. You have to identify the problem, make a hypothesis of how you can solve the problem, see whether it resolves the problem, and then try and repeat that several times until you find the solution. So that is very hard. Well, why is it so hard? And actually cloud and modern technologies have made this harder. So first and foremost, there is a vast amount of configurations. Without taking on Java specifically, Java alone has over 100 parameters to tune. You have many different components, various configuration, tuning, the amount of resources, thread counts, and so on. So the configuration spaces, typically we see configuration spaces with sometimes billion and trillion of combinations. In addition to this application is no longer running on a server right next to you or in the data center where you can walk in and see it. They run on cloud. There's really complicated infrastructure which your engineers have to fully understand and understand in depth the complex interactions between those elements. And then in addition to this, engineers have to be deeply familiar with your application, how it works, how it processes its workload. So that requires a tremendous expertise. And in addition to this, because we have DevOps, because we can push code minutes apart, all of this has to happen not once a year. It has to happen at lightning speed. It has to happen all the time. The result is doing this is just simply beyond the reach of human ability. And let's see how we got there. So we understand that there's a problem. How did that happen? What changed? Well, there's three key things that changed. Number one, microservices came as a preferred methodology of scaling application teams and improving applications. And what happened is instead of having a single monolith applications that you need to optimize, typically written in one language with one set of middleware, you now have tens and sometimes hundreds of microservices. Frequently they're written in different languages, they require different types of configurations, and many have different optimal settings. Some can prefer one, others can prefer a different configuration in order to work at their best. In addition to that, increasing the number of entities that we need to tune, we also tremendously increased the release frequency, starting from annual releases in the 90s to what we see today is typical larger companies in better setups that release every week or every other week, but some companies release every few minutes. So the frequency of these releases and when things can change has increased. So those are the two major reasons why this is just it became so much bigger. And then in addition to this, because of the faster pace of security patches and other bug fixes that happen in the open source world, especially, there are third-party library changes that typically you can't control. If there's a vulnerability fix, you have to implement it right away. And sometimes those can have very significant performance impact. So those are three different factors that just changed significantly the conditions in which we do optimization, which is why it became not possible to run at human scale. So now that we understand the problem, let's look at how we solve this. How do we do this specifically for cloud and specifically for DevOps? The answer is continuous optimization. It is an important third phase in the continuous integration, continuous deployment pipeline. It ends up followed by continuous optimization so that we do this important step. So just briefly, what is continuous optimization? First element is that it aims to increase the efficiency of executing the application. And efficiency sounds kind of vague, but what it really means is performance per cost, number of transactions per dollar, number of transactions per second per dollar. So those are things where continuous optimization can improve the overall efficiency, and that allows you and your team to move that efficiency to increase performance or to reduce cost, or a combination of the two. The second important aspect is that while continuous optimization can work on microservices individually for every service, it can also be extremely good and efficient at optimizing the whole application. So getting multiple services that work together and improving how they work, and making sure that they are balanced so that one doesn't create a bottleneck for the other. A third important element is it allows you to choose what you consider performance. For some applications, that would be throughput. For other applications, that may be response time. For others, it may be the duration of a batch processing. And what is important is that continuous optimization deals with the business important metrics. It's not about utilization of resources. It's not about number of garbage collector exceptions or things that are kind of inside the machinery of your application and its infrastructure. But it is about the business impact. It is the experience of your customers and the costs that you have in order to operate your application. And then, most importantly, it has to run continuously. It is part of the CI/CD pipeline. It is applied to every release, and it works autonomously. It does not require humans and your engineers to interact with it on every iteration. They don't have to take any actions, which would have slowed down the CI/CD pipeline if it was not this way. So these are the four key characteristics of continuous optimization. So before we look at the elements that are involved, let's just look at the process of how continuous optimization works. It starts with code changes. It starts with your team has built new version of the code. The code has gone through the CI stage to be built and tested, and it has gone through the CD stage in which it is deployed. And it may be deployed to a performance test environment, or in many cases, it is deployed directly in production. The next step where continuous optimization picks up is it performs measurements. So observations are a critical part of continuous optimization. So as new code is deployed, the very first step is to measure the performance of that new code so that it can be compared to the metrics and the performance of the previous release. And when I mean measurement, that includes both performance and cost. Obviously, if somebody changed the number of instances or changed different instance type, the cost can be increased. So the measurement here takes into account the performance and the cost aspects. Then the next stage becomes really interesting. It is based on these measurements. Continuous optimization has to make a prediction of what configuration changes can be applied that have the potential of increasing performance or reducing cost. Once that configuration is determined, the next step is to actually apply these changes and implement them in the real system. And again, since this is running in cloud, you already have the pipeline working. That in implementing these configuration changes is fully autonomous. It completes automatically. There's no humans involved in the process. After the changes are implemented, there is a test that is being performed. So if that is running in a performance test environment, you will run a load generator. If this is running in production, then these configuration changes will be exposed to live traffic from your customers. The next step, while this is going on, it is important to measure again. So we have a new configuration in which your application is running, and it is being measured to evaluate it and be able to compare it to all other configurations that the app has gone through. And then depending on, after the measurement completes, the results of that measurement, the performance, the cost, latency, response time, error rate, all of these important metrics are taken into account and updated in a model where they're compared to prior history of this application and its behavior, and then lead again into a cycle of making a prediction of what configuration should be tried next that has the potential of being even better. So that is the loop that continues to repeat. So let's look at the elements that are involved in this process, kind of look at it from a system standpoint rather than from a process standpoint. So the first thing that is important here in the middle of the slide is your application. Your application is always built in various layers. Those layers include infrastructure like the cloud infrastructure, whether this will be containers with their own CPU and memory assignments, or it could be a virtual machine with a given instance type and family. There's a runtime environment and middleware, things like Java virtual machines, and all kinds of different runtime. And then there's your application itself, which may also have key parameters that can affect its performance, things like number of threads, pool sizes, cache durations, and so on. And that application, you also have the CI/CD pipeline in the cloud platform. So when changes to the configuration need to be made, you do that through the cloud platform. The next important element is the optimization engine. And again, different implementations will do it differently. But the optimization platform is the one that actually makes these decisions and controls, calls the cloud platform to make the changes. And last but really important element here is the monitoring. So being able to actually measure and observe the performance of and cost of the application, and then can typically be done through whatever monitoring system you're already using. There's no need to introduce new ones. You should use the ones that your team is already using for monitoring. So let's see, with continuous optimization, what does the CI/CD pipeline look like? So writing code that continues to be done the same way. You have a continuous build and continuous test as part of the CI stage. Then the obvious next stage is the continuous deployment. So this is the traditional CI/CD pipeline. And then the new step, continuous optimization, is kicked off after the deployment. And again, you notice that because of the higher velocity, now optimization actually comes after the deployment. And it is done, again, on every deployment and continues to run all the time after deployment. So again, if you compare it to the previous pipeline, you see that you now do have the stage of tuning, and it is automated. It's made part of the process, and it executes immediately after deployment. So that is all great, but what does it bring? Why do we do that? The three key benefits from continuous optimization is reducing costs, and I will tell you in a minute what we typically see teams achieve, significant improvements in performance, and then ability to optimize your application for metrics that are considered for you, that are for you business critical, customer experience, that affect customer experience and your top line. So what we went through is we introduced the notion of continuous optimization as a third stage in the application delivery pipeline. Its key function is to maximize the application performance while reducing cloud costs and do this autonomously on every iteration. What we see typically teams achieve by doing this is up to 70% reduction in cloud spend. 30 to 50 is something that we see pretty much everywhere. So that is usually the baseline. And then we have seen up to 2x improvement in performance in applications as a result of continuous optimization. And what is also important that continuous optimization keeps doing that on every release. So those maximum efficiencies and adjustments that need to be made are done continuously, and those changes and improvements will continue. So that wraps up kind of the presentation part of our webinar. We'll open for questions in a little bit, so please feel free to post these in the BrightTalk interface. In the meantime, if you're interested in this concept of continuous optimization and you'd like more information, please see the attachments and links in BrightTalk. We have a white paper, a case study, additional information. And also, if you have questions that you would like us to answer directly on your application, in your case, please reach out to our subject matter expert at the address on the screen.
Great, thank you. As we wait for questions to come in, we've got a couple prepared for you guys. And the first is, will continuous optimization interfere with the code in my app?
So the short answer is no. There's two different scenarios. One is when you deploy to performance test environment, and obviously it doesn't, continuous optimization doesn't actually affect code at all. It doesn't rewrite code, it just changes configuration. And those configuration changes, when you're running in production, which is when it really matters, those are usually done in a canary instance. So very similar to the way your team tests and releases new version of the code, continuous optimization can work with canary instances to ensure that new configurations can be evaluated without impacting the performance of the application overall.
Great. I already have APM or app performance monitoring tools. How is continuous optimization different from this?
Mm-hmm. Well, those elements are complementary. So APM tools have existed for a long time. They are tremendous in giving visibility into the applications. They allow you to understand where the bottlenecks in the code are, how your application is performing and handling exceptions. What continuous optimization does is it takes that information, a subset of that information, the business important metrics, and that feeds it into an automatic optimization process. So APM is aimed primarily at humans and visibility and understanding, while continuous optimization improves the performance and costs through configuration changes, and does that autonomously.
Great. And we just got a question asking the biggest differentiation between performance monitoring and ADICO, and I think you just hit it on the
I think we just answered that question. So performance monitoring is essential to understand your application and make sure that it maintains uptime. And then continuous optimization, in fact, uses your existing performance monitoring tooling to feed that as a feedback process into the continuous optimization in order to improve performance and evaluate it continuously.
Great. Can you go a little bit deeper into the improvement cycle and explain why learn and predict are not the same thing? I would think that a new prediction would take into account new metrics already.
Let me see if we can quickly go back to that slide. So learn and predict are significantly separate phases. So learn accumulates information about past performance of older version of this application and what they have done under different configurations, as well as new configurations that are tried with the newest version of the code. And that creates a space, essentially a mathematical model of your application that the prediction engine then uses to predict what is the next configuration that is most likely to improve performance and can be submitted to be evaluated.
Great. Could you maybe go into this a little more? How do we utilize deep learning here to do this?
So this moves a little bit away from the concept of continuous optimization as a pipeline and goes into our products, our company's products, which do implement continuous optimization. Because of the humongous configuration space that we already talked about earlier, billions and trillions of combinations, and the frequency at which this work is done, machine learning, we believe machine learning is the only way by which we can implement continuous optimization at the right scale. So we use a variety of advanced machine learning algorithms, a lot of things that we have built proprietary, and we have patents on this technology that makes that work at scale in large applications and is universal across multiple types of applications.
Great. One last question. How exactly are you optimizing or adjusting our resources today?
So and again, we kind of staying away from the product specifics, and we'll be really happy to talk about the product if you reach out to us. But in general, in continuous optimization, the changes to resources as well as to any other parameters happens through the cloud orchestration platform we use. This may be something that happens directly against cloud orchestration systems like Kubernetes or Amazon API directly, or Azure, or Google Cloud. And that also, in many cases, that can be done through your CI/CD pipeline, so talking to Jenkins, Spinnaker, or GitOps directly. So any mechanism that you would like to use and want to use for configuring your application, continuous optimization is an element of that pipeline. So it plugs naturally in the mechanisms you already have in place.
Great, thank you. We have no more questions, so I think we can wrap it up. Thanks so much to everyone for attending today. We hope you enjoyed learning about continuous optimization. Keep a lookout for our email. We'll be sending you a copy of the slides and a recording of this webinar. And reach out if you have any questions. Thank you.
Thank you very much.